Sempilation is. First things first, few formalities. I won't go into too deeply who I am. I worked at Microsoft for a few years. I went and did my own thing after that. I'm very passionate about language tools and compilers, which if you haven't read the program, gives you a hint about what this is going to entail. In terms of programming itself, I wanted to just clarify how I think about programming. It's about communicating intent to a machine, first and foremost, in my mind, and that informs this talk. And as a field, it's generations old at this point, so we're at this place where we're the most knowledgeable we've ever been about it. We're the most battle-hardened. We have powerful computers, and computing as a field is more accessible than it's ever been. Yeah, I feel like we're in this place where software is kind of getting worse. It's it's anyone who's run Chrome and Spotify and Slack and VS Code side by side on a modern machine and felt it start to chug knows this pain. There's many humorous tweets about it out there, but it's like a real problem. And so I started to think, well, why is that happening? And how can we address that? And I think narrowed it down to these sort of areas. One of them is being this idea of a polyglot developer. So you contribute to different projects across different parts of the stack and use different languages, and maybe for a few weeks you focus on one language and you get rusty on another, and the syntax of that other language starts to change and they add features like streams in Java 9, I think it was 8 or 9, or lambdas in C++. And so when you come back to the language that you haven't touched for a while, you have to spend some time ramping up, and there's extra cognitive load blowing away those cobwebs. And all that is wasted effort that's not getting you any closer to why you're writing the code, and it's fatiguing your mind for no reason. And then we're sort of expending a lot of effort arguing about whether to use an optimized layer like a virtual machine in React Native versus writing native code. And then what we're really arguing there is how good is good enough. And I think one of the reasons some of this software is a little bit less performant than we'd like it to be is because that good enough threshold gets lower and lower. And so I think that is a waste of time arguing about that. Lower barriers to entry in software development, that's ostensibly like a good thing. No matter where you are now in the world, providing you've got the technology around you, you can get into development. But I feel like there's this trend of online 3-week courses starting to supplant the knowledge you get from like a 4-year degree. And what they miss out there is like the computer science fundamentals that I think are essential for writing, for problem solving and writing solid software solutions. And the big tech companies weed that kind of thing out in their extensive, exhausting interview loop, but in open source, we don't have that same sort of loop, and we don't have that same quality control. And we rely on so much open source stuff, which is great, but it's just the quality can be a little bit questionable, and so can the stability of it. And then lastly, using the web as a jumping off point and web browser vendors and standards committees to sort of tell us how we should be building, progressive web apps or what frameworks to use. And they are starting from a virtual machine that abstracts away the platform, and they're predominantly using JavaScript, which is a very flexible, powerful language, but also very loosely typed and allows hacky things to happen and you get away with them. And I think that's fine when you've got some sort of context, but as a wider sort of source of truth of how we should be writing software is perhaps not the best lead to take. And so our current answer is tools like this, which they have this write once, run anywhere, or learn once, run anywhere, which is kind of the same thing in practice for anyone that's used those kind of tools. And it comes down to this idea that one size fits all almost, and that you don't need to really worry about the semantics of the platform that your code is running on. And things that are under the hood or complicated are kind of out of your hands, and we trust that the framework knows what it's doing and does a better job. And it means we don't have those headaches, and we can just get on with what we were doing. The trouble with treating all platforms largely the same is that you get to more humorous tweets where there's this piece of code that's been written in C, but it's using the semantics of JavaScript, essentially. And it's scary to kind of consider this thing happening day to day, and the software that is running on our machines has all sorts of weirdness like this going on. And it's maybe because the person writing this didn't know better or whatever reason. It's just something we should perhaps think about is why we are having these problems we're having. And so if platforms are not all equal, and we know they're not equal, how do frameworks make them feel equal? They synthesize features where they don't exist natively, like function overloading or higher order functions as objects. You know, they do a lot of things in black boxes, and they crowbar a virtual machine in, and then they marshal the data across the boundary for you. And the API to that feels very simple to use and very clean, but the complexity is still there, and the cost to the user experience is still there. And that all comes with a load of framework glue between your app and the user to achieve these magic tricks. And then, because of all that framework glue, when things go wrong, you end up with stack traces that look like this, which I think anyone who have used things like React and React Native, which I use myself, I'm not putting them down, they do a good job. But when you have stack traces like this, it makes your life as a developer pretty soul-destroying, because none of these frames belong to my code. And the error message that you probably can't see, but it says element type's invalid, expected a string. What does that mean for me? You know, the code is so deep in the framework at this point that it doesn't even know what the root cause was. The stack trace is not deep enough. And then what, I'm going to install another npm module where I can interrogate more frames, or, you know, it just doesn't make sense. And then on top of that, the user experience stuff suffers. The battery life performance is poorer than it should be. Long lists are laggy, the startup time, memory usage, the tooling's immature, it's brittle. And I feel like we're in this place where it's because the business is leaning on us as engineers more and more, and they're saying, you know, it's better to have something out there as soon as possible than wait for something that you've sort of spent a bit more time engineering properly. And you feel dirty about that, and you say to them, you know, it's a hack, and they come back with something like, you know, you'll feel a lot dirtier if you haven't got a job and you have to sell your body for food. And you go, yeah, but the user experience is going to suffer. We're going to lose our user base. And they say, you know, that's fine. That if you see the standard of some of our competitors, we're right in that mix, so don't worry about that. And then they also have terrible names, which I put this slide in as a joke, and then I found a real framework with that name. So I just, that's a side point, but okay, so that's the end of the rant section. We can all breathe now. I wanted to set the stage with that because it informs why Sempiler is how it is and what it is. And so now we can go on to the promise part of the talk, which is the Sempiler part. Programming languages have these concepts that are very ubiquitous. Every language has some notion of taking some data, operating on that data through algorithms, functions that encapsulate algorithms, and libraries that have functions, and all these hierarchical layers, and obviously object orientation. So all of these things, these core commonality, these facets, they mean, you know, if you have an idea for a project, you often sketch out in your mind and you work out the flow of data through it, but not necessarily the specific implementation details. And you don't necessarily focus on those implementation details until you're writing the code. So the structure in your mind is agnostic of a platform at that point. And so if we can remove that syntax boundary that gets in the way of you communicating your intent to the machine, then you can just keep focusing on platform semantics and making your code run as fast as possible and get the most out of the hardware you're running on. And so that's the core idea behind sempiling. So you take a source language, and it's a source language that you write every day, whatever that is, if it's JavaScript, if it's TypeScript, or if you're maybe insane, it's PHP. Then it's a language that you're comfortable with, and it has a syntax that's expressive, is malleable, and it feels second nature, and preferably it's strongly typed, because it will save us having to write loads of unit tests if we have tooling that can catch things like interface violations and contracts we haven't followed in the code. So you take your source language that you're comfortable in, and then you take a target context, which is essentially like another language or a platform, like maybe Xbox, and you focus on learning the semantics of that platform. So if I want to render a button to the screen, how would I do that? What are the APIs I need in that platform? How do I add event handlers? And if there's memory allocated for that button, do I need to then recycle that memory explicitly, or is it garbage collected? All of these things are aspects of the target context. They're the semantics of how that platform works that we don't want to abstract away, we want to focus on. But what we do want to abstract away is learning the syntax that I'd have to, if I'm talking about a platform using C++, I don't want to have to learn C++. I just want to learn, okay, if I grab some memory and it's allocated on the heap, I have to then deallocate that memory, So things that sound scary but are actually conceptually we can get our head around. And the scariest part of C++ for me right now is the syntax is so horrific. So you already have a way to say the things to the machine. So let's use that. Let's use that existing knowledge, that source language you're comfortable in. So essentially you write source code, but you have the mindset of the target context that you're writing against. So how would you do that? Well, you do it through declarative APIs. So we have these symbols. In our source language, when we're writing our code, we're referring to symbols, these symbolic constructs that have the same names or the same function signatures or object composition type hierarchy as the APIs that exist on the target platform that we want to compile our code for. So how that looks in practice is, here's an example of me as my source language using TypeScript because I'm very comfortable with TypeScript, I like it a lot. But I want to model the semantics of C++. So in the top image, these are macros that you would find in C++ that you would commonly refer to. But of course, these macros don't exist in TypeScript. They're not implemented there. But crucially, I've used the same typing, like string or int, and the same symbol names, and the same availability here in global scope, as they would feel as if I was writing C++ in C++. And again, below that is a standard printf function, which, if you're unfamiliar with, is kind of like your console.log in JavaScript. And so I've modeled the symbols and the structure of the semantics of C++, but I've modeled them in a language I'm comfortable with, which is TypeScript. So again, I should also say this makes use of the ambient declarations in TypeScript. If your source language didn't have ambient declarations, you could just, if you had a function that returned a number or an integer, return any integer. And the reason that works is because it satisfies the type checker. And we don't care about the implementation of these symbols because your source code, whilst it's written in TypeScript or your source language, is never executed in TypeScript, which is something to emphasize here because it's something that perhaps people miss sometimes with the idea of your code in your source language is purely symbolic. It communicates your intent. It's statically valid. You can verify it using things like IntelliSense because all of those tools work statically too. But it's never going to be executed in TypeScript. So it doesn't matter that those symbols don't actually do anything in TypeScript. What Sempiler will do is change basically the syntax for you. And those symbols will all stay the same, but suddenly, if Sempiler has changed your TypeScript to C++, those symbols do mean something in C++. And so it's the same intent, we've just swapped the syntax, and so then the code will do what you expect it to do. So the good thing about having strong typing, as I said before, is that then we can also provide that validation as early as possible about you violating constructs. But here's a more in-depth example. Is everyone familiar with what like a pointer is, roughly? It's like this thing that points to an address space in memory where you can read some data out of. Now, in higher level languages like JavaScript, that kind of thing is abstracted away and it makes life really pleasant to work with. But if I was writing something that was very performance focused, maybe it's a video encoder or I know something that exchanges data on the network or even a game, then I want to be having close control over memory. And so if I wanted to use Sempiler and I wanted to operate with pointers because I'm targeting C++, then I can model C++'s pointer models, pointer constructs just like this. I can say that a pointer has this generic type t and this property pointy of the data it points to, so that might be a number or a string. But pointer itself is also a number, so then I can add offsets to it and point to different parts in memory. And then we have these complementary functions that come with that address of, where given a variable, I can get the pointer to it. Now, in C++, that address of is actually just the ampersand symbol, the operator. But because operators are conceptually functions, this is along the same logical lines, so it's semantically consistent. And then the bottom two are just about where that memory lives, which I won't need to drill in too much, but suffice to say, rather than me just calling new on an object like I do in JavaScript, in C++ I can have more control over where that object, that memory for that object lives, and whether I want the garbage collector, which C++ doesn't have, or if I want it on the stack and it will disappear as soon as I exit the scope, or I have to keep hold of that memory and it's my job to tell it when to be deallocated. So the point here is that these are all concepts that don't exist in TypeScript, but I can still write code against them if I'm thinking about C++ as a mindset. And then when I give this code that I've written against these APIs to Sempiler, it will become valid C++. And so now what I'm going to do is switch to VS Code quickly and hope that we don't have any technical issues and just show how that's possible. So you'll have to bear with me because I've got this ergonomic situation where I'm using a keyboard here and just having a comfortable neck position. But when you have Sempiler in your project, it will pick up the fact that you've got this semconfig file. And there's a couple of things just to see, like the input path is basically this source directory here. Should I make this bigger? Can everyone see it? Let me make it slightly bigger. Okay, that's probably too much. You can have too much of a good thing. And then this output div path, which is where we're going to compile to, and we're just saying C++ is our target. But you'll see here that I'm writing code in TypeScript. So let me take this down. So here at the top, I've got this struct, which again, we're used to in JavaScript, either using prototypal inheritance or lately classes that are kind of wrappers around that. But in C++, we can have this idea of a struct, which is just another type of storage for data. And I can refer to these macros that we saw earlier. And if here, this is interesting, because I'm saying if one of them's defined, then I can assume I'm on Windows. If Apple is defined, I'm on Mac. Now again, this code, I couldn't execute it in TypeScript because none of them do anything in TypeScript. But when I sempile it, we'll see what happens. And then here, the semantics of C++ and Java and C# and languages like that all say we should have a main function as the entry point. In JavaScript, we don't have that idea. We just have some index file that starts the whole program. So I've had to have this C++ main function. And then I'm using these APIs we just saw, like I'm going to allocate my foo thing on the heap, but this greeter one is going to be on the stack. And then I'm going to call a function on there. And then because I allocated foo on the heap, I'm going to then recycle that memory. All of these, again, concepts that I wouldn't normally do unless I was thinking in a C++ mindset. And greeter is just a simple call. But the important thing here is that this is a declarative call, again, to a printf function that doesn't exist where we are, but will exist. So if I open this command and then I call run, then it says it's sempiling, which you see here. And then it's finished with errors and it beautified. And then what I also have here is this ability to add a post command. And it's got this environment variable of the files we sempiled. And I'm just passing that in my post command, which is very ugly script. I'm just basically passing it to the C++ compiler to create something that we can execute. So that process created our out directory. And we can see that our hello world code, if we put it side by side with what we started from, which is here, you can see that there's this parity of almost one-to-one relationship. So now, if something was to go wrong and it was to say, this line was a problem for some reason, we can map it back to our original source code. We don't need these source maps. We don't need these stack traces with huge layers of framework glue because there is no framework here. It's just a syntax swapping exercise at this point. So that makes debugging so much more pleasurable, if debugging can be pleasurable. And so, yeah, you get this experience where you can see the lineage of your code. The tool in the middle hasn't injected all this glue and black box magic and stuff. There's no tricks here. It's just what you see is what you get kind of thing. And so anyway, we've ended up with this executable here. And so if I go to the terminal and I just try and run that, you can see that macro was defined on Mac OS X because I'm on Mac, but the Windows one obviously wasn't defined because it didn't tell us Windows. So we've written C++ targeted code, but in TypeScript. And we haven't had to use any frameworks to get there, or any virtual machines or anything like that. So now I can hopefully switch back to this thing. How are we doing for time? Okay, we're good. So what we get from that is, like I said, it's easy to debug because the stack traces are clean. And then this idea that actually if you had a team that was working on some other language like Java, and you wanted to contribute to that project, it's on you. Just learn the semantics of how Java works, like the stream APIs, like I mentioned earlier, or just some things about Java. It has a main entry point function. That's semantic to Java, but not to JavaScript, like we said. So if you learn those semantics, you could use something like Sempiler to write in a language you were comfortable in, but still be a contributing member of that that group that are working on something else. And then there's no bloat. We said there's no layers in between. The code you write just goes into Sempiler and comes out as the language that you're targeting on the platform. There's no tricks here. And that's what frustrates me when I lose performance in my application, and then I don't know where that performance has been lost until I profile. And then I'm having to look in someone else's code and see where the problem is. And I just want to care about my code. So you have this idea of more control over the performance. You can still use libraries, just like you don't have to reinvent the wheel. But it's just, you're not beholden to, say, in the case of virtual machines, because in React Native I have to cross a virtual machine boundary, or because in Electron I have this same restriction, I'm beholden to that framework to cross that boundary for me. Whereas in this case, because there is no boundary unless you created it, then you have total control over how data flows through your application. So it's on you whether you write something good. It's not necessarily the framework holding your hands or holding you back. The other thing to mention is just that this idea of going from a source to a target context is completely agnostic. We started with TypeScript and we went to C++, but in a real-world example, which is this app Hipfire that I recently wrote that's coming out soon, plug, that, like I said, was React Native. So I use React Native. I've used it extensively, and I think it does a great job. But here, React Native is a very foreground-focused framework, so try saying that fast 3 times. The problem with that is it has to be in the foreground to get the most out of it. Because it's spinning up this virtual machine, it's painting to your screen like a web sort of experience would feel. When you want to do stuff in the background, you're left doing these strange, hacky things because React Native is not really designed to be running in the background on the phone. And so I needed to listen to your location as you move around the city, because Hipfire picks up homeless projects and charities as you move around the city that are near you, and you can learn about them, you can donate to them, things like that. But I don't want you to have the app out on your phone like a Geiger counter looking for charities, because who's going to do that? So I looked at some of the existing solutions that use background location. They were on GitHub, they were all a little bit buggy, they all didn't really work. And I thought, well, if I could just write the Swift myself, then I can use something like Sempiler as a proof of concept and get pure native code that does register background listeners and talks to my server and stuff, but I haven't had to learn Swift. I've just had to learn the name of those APIs. And that proved to be incredibly time-saving, because Swift syntax is very like JavaScript. But that makes it even harder, really, which sounds counterintuitive. But you find that as you're writing and you're focusing on your problem you're trying to create, your mind is slipping into writing JavaScript syntax because it looks visually the same. And anyone who's used Xcode knows that you have to wait about 5 seconds before Xcode catches up and then gives you a littering of syntax error problems. So by, again, removing that syntax boundary, I'm able to just focus on writing what I need, which is code to listen for your location and send it to my server and operate on it and whatever. And I don't need to worry about Xcode arguing with me about me missing semicolons, or using the word function instead of func, which is all like just really, really boring stuff to have to worry about. Your skill as an engineer is how you take someone's idea and make it do something on a machine, not whether your braces and your semicolons and stuff are in the right place as you're doing that. So coming to the end now, I just wanted to suppose a more hypothetical use, and that's because WebAssembly, which I know there's another talk, I think prior to this was on it. WebAssembly, if you don't know, is like this low-level binary-like format that will mean that things that run in your browser will execute quicker, essentially. But the cost of that performance is a more constrained set of operations and features than JavaScript gives us. So naturally, there's a lot of web developers asking the question, okay, how can I change my JavaScript to WebAssembly, or that kind of idea? And the truth is that you can't really do that because it is a more constrained operation set. So this is going to sound a bit crazy, but it's kind of, for my own humorous indulgence as much as anything, but by all means try it. Emscripten rather, is a C++ library. And what happens there is it has these APIs and it will produce WASM when you use it. So C++ developers can use Emscripten to create websites and web apps that are very performant. But we know already from this talk that Sempiler goes from TypeScript to C++. So extrapolating from there, if we wrote in our TypeScript, because we're comfortable there, against symbols that belong to Emscripten, Sempile that C++, follow me so far, right? And then execute that C++, what we get out is a WASM web app that is ultra performant, but we've still been able to write in a language we love like TypeScript or JavaScript. And so our developer experience is the same because the friction is all in the toolchain. That's all compile time. None of the user experience is harmed by that, and we can hide that toolchain of interconnecting steps just behind, a script. So we're able to theoretically then write WASM apps from TypeScript and JavaScript, which is kind of the whole point of why people are asking that question. So yeah, I mean, I haven't tried it myself, but I hope to, and if anyone does before me, then tweet me the results or whatever. So yeah, just to sum up then, because we're coming to the end, it's not a new language, Sempiler. It's not a programming language or anything like that. If you've already got this by this point, I apologize for laboring the points, but it's not a framework either. It's not coming between your code and the machine and the hardware. There's nothing injected, and the whole point is your eventual code that comes out Sempiler should look like the code that went in, just with a couple of those, semicolons and stuff moved around and braces and what have you. So it's not an interop either, which someone who I explained this to thought it was an interop. It's not like it's running TypeScript and also a C++ runtime or C# runtime or anything. Literally, it's just swapping the syntax. And so whilst it's explicitly not write once run anywhere like some of these frameworks are, there's no reason why you couldn't do that in cases. If you had a number like the trivial square root function that takes a number and outputs a number, there's nothing particularly platform specific about that kind of function. So you could share that between multiple code bases. And whilst that's kind of a boring example, it's just showing that Sempiler is not against the idea of sharing code between platforms, because we all have deadlines and we all have the business side who aren't so idealistic about code sometimes. So what it therefore is a transpiler. It should be intuitive therefore to use and low cost therefore to start using it. You shouldn't have to say to people, I need 2 weeks to learn this kind of thing. It should be like, okay, I see what's going on here. Within a couple of days, I'm up to speed. Zero overhead abstractions. This isn't about what is good enough. It's about the code you write being what comes out. Validating that code statically, so you don't have to spend your life writing and maintaining unit tests, because that's fairly boring unless you like that. And I'm not saying you're boring if you like that. Everyone has to do it, sadly. And then, the whole point is it should boost your productivity. It should not slow you down. And hopefully that's what you get out of those things above, And some people might say, but if you're taking away the syntax problem and you're replacing it with me having to learn platform semantics, isn't that just one problem for another? And what I'd say to that is that learning syntax, again, doesn't really get you close to problem solving, whereas learning the platform you're operating on or your code is going to run on in your user's hands is something you should care about, because you want your user to have a captivating experience. So learning about the platform and the context that your code is running in is actually very beneficial to you being able to write that code. Whereas learning just the syntax is kind of not something I consider beneficial. It gets in the way if I already know a programming language well. And then lastly, knowledge sharing. And this is cool because if you have an app and you're big enough to run on multiple clients, you have multiple teams, then you can hope for a more consistent UX, because you can have informed conversations with that team on a completely different platform because you know the semantics of what they're dealing with. And it won't be like we had a problem at Microsoft where the iOS team wanted to do this fancy animation thing, and it wasn't until the Android team got late down the line they realized they couldn't do the same thing because of the hardware acceleration and stuff. So you can have more informed cross-collaboration in big teams. So there's the website if you want to learn more about it. The current version is the one I showed. That's like a proof of concept. The next version at the end of the year is a lot more optimized and a bit more pleasant. So that will be coming at the end. But you can grab the latest one as a Visual Studio Code plugin for free. So try it out. And then that's me on Twitter, Cometh the Nerd. And I'm also on LinkedIn, and my name is thankfully unique enough, or maybe that's not a good thing, that you can find me quite easily. So feel free to shoot me a message. Otherwise, I have probably left 5 minutes. That's okay for questions. So if there are any. Yeah. Oh, I think there's a mic coming to you just for the recording.
Thanks for the talk. My question is, if I got it right, then you anyways would have, well, you have to study the semantics of the target language first, right?
Mm-hmm.
So if you're anyways gonna do that, why would you, well, why wouldn't you then just write, the code in that language like right away?
Because the semantics are basically like what the functions are called and what they return. Whereas writing syntax is a lot more involved, because I come back to languages that I haven't used for a while, and I'm writing statements syntactically invalid code, right? And it's not until the compiler tells me that, and that's very slow as a feedback loop, and it's very frustrating because I'm like, I know what I want to say, I know I want to use this function, but the thing that's getting in the way is just the symbols I'm using to type. Whereas the semantics, what I mean by that is you just learn the name of the APIs, and because you know in your favorite source language how to invoke a function and how to store that result, you haven't had to invest time fighting with the compiler writing the syntax. You just need to go, okay, the function on my target platform is called foo, whereas in my source I was used to writing bar, so I'll just use foo instead. And so what I found with using this tool and developing this tool is that it just saves me from that headache, because syntax at that point gets in the way. You've learned a programming language that's expressive. Why should you need to learn another one just to solve a different problem? What you're really thinking about is where that code's running, and that's the semantic side of it versus syntax, right? Does that
Okay,
answer
thanks.
your question? Oh, yeah. Oh, and then...
I will be next.
Yeah, so again, it's pretty cool. I love this kind of idea of like you removing yourself from the compilers and kind of you thinking in the way that you used to thinking and moving into something where it's a really performant or whatever.
Mm-hmm.
I'm curious, have you thought of maybe a possibility of making it less one-to-one, so there's maybe like a code mod somewhere between? Because not that, like, I understand the value proposition of it being one-to-one,
Mm-hmm.
but there may be, like, let's take, for example, a JavaScript programmer that doesn't actually know what pointers are. So
Yep.
they've never used something like pointers. Could you do something theoretically where Sempiler actually took something that doesn't exist in C++ or whatever,
Mm-hmm.
but it's something like an API that's put into your TypeScript or JavaScript, and then it wrapped a pointer and a dealloc or something like that?
Yeah,
Is that possible? Is there a possibility?
It's perfectly possible. The thing that it's sort of I don't want to come across too purist with this, with how I've been talking about it. The thing I'm trying to avoid is that I suppose if you're comfortable with using frameworks and then the tooling injecting code in order to give you the comfort and flexibility, then the whole point of this is to make your life easier. So if that makes your life easier, it's not. I don't want to be opinionated and go, no, you can't do that. If you're going to buy into this, you can't have comfort. Yeah, the thing that I want is that it doesn't inject all that stuff for me. But I think there's probably a line where that's useful, and as long as it doesn't go too far where the code I see is stack frames like we saw in the React example, then probably, yeah. I mean, there's nothing to stop you doing that. The point I was just trying to make today is that you can maintain that symmetry as if you'd written that target code. But yeah, pointers as a concept are quite involved, and maybe if you're a more pragmatic web development background, you don't want to have to deal with the guts of memory management. We've solved that problem in higher level languages. You want to feel that way again, but just target a lower level, then yeah, you could use an abstraction and something along the tool chain that injected that code.
I'd kind of see it as like, instead of you having to do it, because it seems like you building the thing, it needs to be no opinions at all, but maybe a team would opt into a thing or something.
Yeah, absolutely. There's no reason why you couldn't have that. Yeah, for sure.
Yeah, hi, thank you. As I understood, using Sempiler, I losing some features of TypeScript, and I'm losing some features of target language.
Not
because,
quite.
For example, in C++, I can define two functions with different numbers of arguments, and each of these functions will have different bodies. But I can't write this in TypeScript because, for example, VS Code will say, "Hey, man, you are
overloading,
doing something wrong."
Are you talking about features like overloading not existing in your source language, right? Yeah. So the way I've gotten around that at the moment is allowing you to do that and then just suppressing the error message, because the TypeScript compiler, the TSC that Microsoft gives you, is opinionated to the point where it's saying, well, I'm compiling your TypeScript as if it's going to run in Node or the web browser, but what you're doing here is saying, I'm writing TypeScript, but it's not going to run in that context. So we intercept those error messages and suppress them where they don't make sense. And if there's a way to divorce the parsing and lexing and like building the syntax tree from actually the TypeScript compiler having those opinions, then I hope to find it, but I hadn't found it thus far because the documentation's quite not as in-depth as I'd like. But yeah, in that case, because you're writing with the C++ mindset where you are allowed to function overload, then you would be allowed to function overload, and we would just catch that error and suppress it. So you want to feel like the tooling isn't fighting with you. And in this case, because the TypeScript compiler is very tied to web context, it does fight with you. So yeah, we just catch them at the moment. But yeah, like I say, the current version is a proof of concept. The second version has learned from those kind of things. And by all means, use the plugin and give me more feedback, and it will be even better.
So, and we can suggest that we will have something about source maps.
Well, the point of having parity between artifacts should alleviate the need for source maps. If you come to the point where you are having tools in the middle sort of synthesizing features, then yeah, you could have source maps to map them back, because you want your debugging experience to be able to step through and things like that, yeah. So that's totally open-ended and something that it could support.
Okay, thank you.
Okay. Okay, I think we're done, but grab me afterwards and we can have a chat. All right, thanks everyone.